Hey guys, how we doing? Hopefully we're catching the concept of the trig ratios and seeing that all it is just a name for how two sides in a triangle, right triangle, relate to each other. And we're not making a huge jump here in this next section. Really, what we're doing is just applying it to real world problems. So really, this example is almost exactly the same as what we were doing on the last slide of the last video. And so if we have a triangle like this and we're trying to solve the triangle or trying to solve for x specifically here, then again you need to look at that angle and see that the side we're looking for is the opposite side compared to that angle. The 12 is the hypotenuse, and so which trig ratio uses opposite and hypotenuse? That would be sine. And so we set up the equation looking at the sides that we know. Sine of 35, because that's the angle we're talking about. Sine of 35 is the opposite over the hypotenuse, so x over 12. And you just algebraically, you need to know how to solve that equation. And so you would multiply both sides by 12, and that would be 12 times sine 35, and then plug that into your calculator, round it to the nearest 4 decimal places, so 6.8829 is the approximate value of x for that. All right. So that one's basically the same thing. Now this next one is just a little bit different in that the equation just works out a little bit differently is all. And so this one we actually have two variables we're trying to find here. Okay. And so the first equation that we can set up is looking at that 65-degree angle. If we're trying to find W is the opposite side from that angle. 3, the one we are given, is the adjacent side. And so we need the trig ratio that uses opposite and adjacent, which is tangent. So the tangent of 65 is W opposite over 3, the adjacent. And so to solve that for W all by itself, same as the one above, you multiply both sides by 3. So you get 3 tangent 65 is W, and then again if you plug that into your calculator, it's going to be 6.4335 is the approximate value there. This next one is the one that's just a little bit different. And so to set up to find Y, since Y is the hypotenuse, and again, now even though we found W, you don't want to use it. You don't want to use, what would that be? Sine. You don't want to use the sine here to get the opposite W over Y, because that's just a snowball effect. You got that one wrong, you're going to get the next one wrong for sure. So we always want to go back to the given information. So we're going to use the 3 that was given to us, and so that side is the adjacent. Trying to find Y, which is the hypotenuse, so we're going to use cosine, because that's adjacent over hypotenuse. So cosine 65 is equal to 3 over Y. Now notice that the variable is in the denominator. Okay, so you got to be careful here. This is the kind that switches. The Y and the cosine 65 switch places to get Y by itself. Okay, but now we're dividing by cosine 65. So again, you just have to be careful plugging that into your calculator. 3 divided by cosine 65. And then you got to hit equals. You have to make sure you hit equals at the end. Otherwise, what's on the display is just the cosine of 65. So you have to hit equals at the end. And you should get Y is equal to 7.0986. So try that one in your calculator right now. Make sure that you know how to use your calculator to do that, and make sure you get the same answer. Okay?
And that was a good point you made there at the end about checking things.
Yeah. Okay.
All right, guys, so we're going to start looking at angle of elevation and the angle of depression. And this is pretty cool because this is something you do all the time. Naturally, you just don't think about it mathematically.
Right.
But the angle of depression is the degrees from which, from the horizontal to the object. Okay. So if you're looking, up at something, or down at something, that's called the angle of depression. Depressed means I'm sad. When you're walking around and you're depressed, your head is usually looking to the ground.
Down.
And then and then the angle of elevation is the degrees up from the horizontal to the object. So when you're feeling good, your eyes are usually up. You elevate, and so when you're looking up, that's kind of the idea of this angle of elevation. If you look at the picture, it kind of gives you a pretty good idea of the young man looking up at the light tower is using his angle of elevation. And if somebody was in the light tower looking down at the young man, they would be using the angle of depression because they're looking down towards him. So that's kind of the idea of elevation and depression. But basically, we can use trig to work through. These are sometimes even Pythagorean's theorem. But that's the idea of more of a real world thing, is this idea of elevation and depression.
Right. Yeah. No, you just got to keep them straight from each other is all.
Yeah.
Yeah. Yeah. So keep going.
Yeah. So here's an idea of this. You're skiing on a 1,200-foot mountain. The angle of depression is 21 degrees, about 7 point... Oh, wait, never mind. about how far do you ski down the mountain. So I was wondering what that's just the slide thing. So here's how it would look, guys, if we were to draw this out. Now notice the drawing is not scaled, but anyway, so you're the skier coming down, and so you're using this angle of depression because you're up high looking down to where the bottom is, and you want to try to figure out how much longer you have to ski. So basically, we're going to use our trig here to kind of figure this out. Now, they told us that the angle of depression was 21 degrees, okay, and now they put the 1,200 feet because they're showing you that he's 1,200 feet up, from the base of the mountain up. And so we don't want to use that one, though. We want to use the distance looking straight ahead and then the angle of depression looking straight down, okay? So that's how we make our right triangle there. And so we know that the angle was 21 degrees. It said that up in the problem. So now we basically look at our information and decide, okay, I've got a 21-degree angle, I've got a hypotenuse, and I've got a side opposite my hypotenuse, so I want to use sine here. And so I'm going to set up the equation as sine 21 equals the opposite, which is 1,200 feet, over x, which is the hypotenuse. Okay? And so there's my equation. Sine 21 equals 1,200 over x. Do a little cross multiplication here. And so this is that one, like Mr. Scritchfield says, when the x is on the bottom down there, we're going to switch the sine 21 and the x, and then we're going to get x equals 1,200 over sine 21. Plug that into your calculator. Be careful here. Remember, this is 1,200 divided by the sine of 21, and we get approximately 3,348 and a half feet, and that will go up there in that box. Oh, they took that out again, but whoops. But anyway, so that's how far down you have to go. I mean, pretty much a really good way to understand trig a little bit better and how trig is actually used, to figure out distance.
Yeah. And so when it's an angle of depression, just kind of put yourself in the skier's position.
Great point.
And your eye view is straight out. And so that's where we're looking for the angle of depression to be from, is what would be straight out from there. The point they're trying to make with that side 1,200, I think, is just that we're using that upper triangle and not the bottom triangle, because the angle of depression goes from his eyesight there down. So the 3,000 feet is how far down the mountain it is to ski. So, all right? So what if we are a pilot? So a pilot is looking out her plane at an airport. The angle of depression, so again, she's up in the sky. Angle of depression is 29 degrees this time. Okay, if the plane is at 10,000 feet, how far is it from the airport? Okay, and so as we look at a diagram of that, the plane's 10,000 feet up. Okay, angle of depression is 29 degrees, and so again, we're not going to use the bottom triangle here. We're looking at the top one because we're talking about angle of depression. So the angle of depression is 29 degrees. It would be like her eyesight out the front of the plane there. Okay, and the plane is 10,000 feet up. That one ends up being 29 degrees as well. And so we are looking at trying to find the hypotenuse of that right triangle there. And so again, we have the opposite side given to us, and we're looking for the hypotenuse, and so we're going to be using sine here. Okay, so the sine of 29 degrees is equal to the opposite 10,000 over the hypotenuse x. Again, we're going to swap the x, because if you multiply both sides by x, then you can divide both sides by sine 29, same thing as swapping them. So x is 10,000 divided by sine 29. Make sure you hit equals at the end of this. Okay, and it comes out to 20,626.7 feet is the distance that that plane has to fly at that angle to get down to the airport. Okay, and certainly these types of calculations are what pilots are doing all the time. So, all right, so make sure you understand how to use your calculator again there. Okay.
All right, one last example here is a mountain climber stands 300 meters from the base of a cliff. The angle of elevation to the top of the cliff is 58 degrees. What is the approximate height of the cliff? So now, we're sitting at the bottom of a cliff looking up, so now this is going to be the angle of elevation. So basically it's from where you're standing to the base of what you're looking at and then up from there. And so when we go to put that 58 in, it's from where you're standing at looking up to the top of the cliff there. So that 58 is going to go right there from basically where his head is up to the top of the cliff. And then we know that the mountain climber is 300 meters away from the base, and so we want to figure out how far it is, or what is the elevation to the top of the cliffs. Now be careful, we're not asking for the hypotenuse here, okay? We're asking for the height of the cliff. Notice it's also in yellow on the drawing. That's what we want, is the height. So now we're going to put our x over there, hopefully. Yes, there it is. And so now we want to find the opposite side from that 58, but we have the adjacent. So when we have opposite and adjacent, We want to use tangent, so we're going to set up tan 58 equals x over 300. We have a proportion here, so we're going to cross multiply, and we're going to get 300 times tan 58. And then all you got to do is plug that into your calculator, and that cliff is approximately 480 feet high. I mean, pretty simple stuff here, guys. If you understand the trig, this is just going to allow you to kind of wrap your head around it a little bit more. I mean,
and that's why we were emphasizing in that last video that
Yeah.
it's critical to understand those ratios, because we're just going to do this over and over and over again.
Yep.
But these are fairly real-world applications of what trig is used for.
Yep.
So,
I mean, you could use this to figure out how far up you had to climb a mountain if you weren't sure.
right? Yeah. If your
Yeah.
ropes are long enough and so
Yeah.
on. Yeah. Okay, so we'll be doing some worksheets on this and some other examples and practice in homework and so on. And so we'll see you guys in class.